So first I will discuss the tensile failure modes of anchors, and then we will jump to the shear failure modes of anchor. After that we will discuss the strength of anchors and then the terminology part. So this will be the overview of our video number 2. Now if you look at the scope part of chapter 17, anchoring to concrete, you can clearly see the design of anchors in concrete used to transmit load by means of tension, shear, or combination of tension and shear. This means that we are designing our anchor bolt based on the load that are tensile or shear in nature or their combination. So now first we will see the tensile failure modes of anchors. Now you can directly jump to the figure 17.5.1.3 failure modes of anchors. Now here we can see first the tensile loading. Now tensile failure of mode of anchor, first one is the steel failure. Steel failure means that it will occur when anchor bolt reaches its tensile strength limit. Means our steel of anchor fails in tensile strength. So first is the steel failure. We can say our anchor bolt itself fails in tensile strength. Now the next one is the pullout. Anchor pulls out of the concrete without a steel failure and without concrete cone failure at the installed embedment depth. Basically, the anchor itself pulls out. When we apply n kilonewton of the force, our anchor pulls out without any steel failure or concrete failure. Now the third one is the major one, that is the concrete breakout. The failure occurs when tensile forces on anchor causes the surrounding concrete to crack or form a cone-shaped fracture, leading to a portion of concrete breaking away around the anchor. So we can say that when the tensile force applied to the anchor, a cone type of failure occurs in the concrete, or we can say that the anchor pulls out containing the surrounding concrete, which is in form of cone shape. Now this is the concrete breakout failure. Now the fourth one is the concrete splitting failure. Occurs when tensile stresses induced by the anchor leads or exceeds the tensile strength of concrete. Means tensile stresses that are induced by the anchor basically are much more higher than the tensile strength of the concrete. So concrete splits into the parts, causing crack formation along the anchor line. So this is known as the concrete splitting failure. Now the fifth one is the side face blowout failure. It occurs when anchors are placed close to the side face of the concrete member. Anchor is placed very close to the side face of the concrete member. The portion of concrete near the side face of anchors pulls out due to the tensile loading. Now we can say that anchor is placed very close to the edge. So the stress distribution becomes uneven, leading to more tensile failure. Now this is the side face blowout. Now the next one is very exclusive for the bonded anchor. So if there is single anchor which is bonded to the concrete, then it may fail in bond failure. Or similarly in the group, if there are group of anchors, so our anchor may fail in bond. So it is known as bond failure. It is exclusive for the adhesive anchors. Basically the adhesive bond between the anchors and surrounding concrete fails under the tensile loading. So these are the tensile load failures. Now we come to the shear modes of failure. Now the shear loading. So our first failure is steel failure preceded by concrete spall. concrete spall. Now, what does it mean? So it is a local surface cracking or spalling. Spalling means local surface cracking. Now, so there will be local surface cracking near the anchor due to stress concentration. So this cracking due to stress concentration. So first there will be stress concentration due to which a local failure will happen in the concrete, but it will not be a major one. And then finally we can see that our anchor fails in shear. The shear strength of anchor is very low as compared to the shear stress. Now this type of failure is also known as shear failure. Now the next one is the concrete pryout for anchors far from the free edge. Now we can see that there is a shear loading. Now pryout failure begins with the rotation of anchor under the shear load. So this is the anchor and this is the shear force, and this will be the lever arm. So what happens? There will be rotation. So now due to rotation, we can see that there will be concrete failure. So this rotation generates tensile forces in the anchor bolt due to lateral deformation and eccentricity between the acting shear and resultant resisting forces in concrete. So a lever arm will be formed, and due to this there will be concrete failure, and this is known as concrete pryout for anchor far from free edge. So we can see that this is the free edge and the concrete failure is happen far from the free edge. Now the next one is the concrete breakout. Similar to the tension concrete breakout, this is the shear concrete breakout. So we can say that the failure occurs when the applied shear force exceeds the concrete capacity to resist it. So there will be concrete failure. Now this one will be the sideways. Force is acting here, so failure will be in direction of force. Similarly here we can see that the force is acting upward, so the failure is also in the y-axis. If this is the y-axis, so the failure in the y-axis. And if this is the z-axis, so we can say the failure in the z-axis. So these are the failure modes of anchors in tension and shear. Now let us jump to the terminologies used in the chapter 17 ACI code. So we have discussed the failure modes. So based on that, we can also conclude the strength that can be considered. Like we have considered steel failure in tension. So we can consider the tensile strength of the anchor. Similarly, we have said that there will be shear failure of anchor. So we can say that there will be a corresponding strength of the anchor that is known as shear strength of the anchor. So we can jot down all these strength now. Now strength of anchor shall be based on the following design model. So based on the failure modes, we have just extracted the strength. First one is the steel strength of anchor in tension. Second one, concrete breakout strength of anchor in tension. Third, pull-out strength of anchor in tension. Fourth, concrete side face blowout strength of anchor in tension. Fifth, bond strength of adhesive anchor in tension. So these are the tension one. Now the shear one. First one is the steel strength of anchor in shear. Seventh, concrete breakout strength of anchor in shear. And the eighth one will be the last one, that is concrete pryout strength of anchor in shear. So steel strength of anchor in shear, concrete breakout strength, pull out strength, side face blowout, bond strength. These all are in tension. Now next one is the shear one, steel strength, concrete breakout and concrete pryout. So we have to design our anchor bolt considering these strengths. We have to find out the strength and then compare it with the stresses. And if the stress, we are also considering the reduction factors. So we will reduce the strength, this raw strength, we will reduce this raw strength and then compare it with the stresses. If stresses are less than this reduced strength, then we can say our design is safe. So we can say these are the stresses. These must be less than reduced strength. So if we consider this, so basically this is the design methodology used in ACI code. Whatever the stress is will be lesser than the reduced strength, and these are the strength. Now we will consider the terminologies. What are the terms considered for the strength and stresses? So let's deep dive into that. Now we need to understand the phi. Now here phi means strength modification factor. Basically, to reduce strength, we use some factor which is known as phi, strength modification factor. It basically accounts for uncertainties in material properties, installation quality, brittle failure behavior, and load effect. Now, phi for anchor in concrete and anchor reinforcement shall be in accordance with table 21.2.1. Now we will see table 21.2.1 where all these phi values are written. Now 21.2 we can say strength reduction factor for structural concrete member and connections. Strength reduction factor phi shall be in accordance with the table 21.2.1. Now we can say that chapter 21 is regarding the phi factors. Now this is the table 21.2.1 strength reduction factor. Here we can see anchorage conditions. Now here we can see that if we are designing anchor steel in tension and in ductile case, we have to take the factor as 0.75. Anchor steel tension non-ductile 0.65. Similarly, for the concrete failure of anchor in tension, non-redundant and redundant, we have to take 0.65 and 0.75. So in anchorage condition, we can see all these factors written. Now here one means anchor components such as bolt or sleeve, and two is used here. Ductility established in accordance with ACI code 355.2 or ACI code 355.4. Now these are the anchorage conditions, and in this various values are written for the modification factors. We have to take the value from this table. Now let us jump to the terminology, the final part of the video. So our first one will be N. N denotes for the tension and V denote for the shear. Our first terminology. Now we have seen that there are one is forces and other one will be strength. We have to compare the forces with the strength. Basically there will be one applied load, applied forces, and on the second side we have strength. Now what we generally do, we will increase this portion and we decrease this portion and then we compare them. So we can say that the factored load, factored forces, or we can say factored load is compared. We will compare it with the reduced strength. So this is how we are designing the anchor. Now the factored load is basically how we show it. So if there is tension N or there will be shear, and in subscript we write U. So U means that it will be force, applied force. And strength, for strength what we write basically, so strength is for the steel and for concrete, and if there is steel, so N means tension, V means shear, N means tension, V means shear. So here S This is for the strength, and for concrete it will be C. So this is the basic, very basic of ACI code. Now we will use this and generate our other terminologies for the breakout strength and other one. Now first we will discuss the stresses. So first one is the NUA, which means factored applied. A means applied tension. N means tension force. Now there is nothing written here, G or anything, so we will say that it is for the single anchor, on single anchor. Similarly, if there is written N U A and then I, it means it is factored applied tension force on individual anchor in group. Okay, on individual anchor in group of anchor, in group of anchor. Similarly, we can write NUAG, which means factored applied tension force on group of anchors, on group of anchor. So first one is the NUA, factored applied tension force on single anchor. NUAI, factored applied tension force on individual anchor in group of anchor. NUAG, factored applied tension force on group of anchor. So this is for the tension part. And if we just replace here N with U, and here the tension one with shear, so it become for the shear. VUA, VUAI, VUAG, so it will become for the shear. So we have discussed the forces part. Now we will focus on the strength part. So currently we are capable of understanding NUA, NUAI, NUAG. Similarly, VUA, VUAI, VUAG. So we can understand these terms. Now we will focus on the strength part. Now with the strength part, we apply the reduction factor phi, which we have already learned. So phi, and then we will consider NS. So this will be the common part. Phi means reduction factor, which we will consider from table 21.2.1, reduction factor. And here subscript S means strength, and this N means tension. Now let us focus on other terms. Our first one is phi NSA, which means factored tensile strength. Here factored means reduction. Tensile strength in tension of single anchor. Next, phi NSBG, which means SB. SB means side face blowout. So factored side face blowout in concrete. So factored concrete side face blowout in tension for anchor group. Now the same part, if we consider again, in which we reduce this G part and consider the same right hand side, copy it and then again paste. Now this will be for what? For tension for single anchor. We will reduce this part and here we will write single anchor. Okay, so we have considered factored tensile strength of tension single anchor, NSB and NSBG. This is for the side face blowout in tension for anchor group or for single anchor. Now next one will be the phi NCBG, which will be factored concrete breakout strength. Breakout strength in tension and for anchor group, because here G means for anchor group. It will be for anchor group. And if we copy the same line again and paste again, and now here we are only considering NCB, so it will be what? For single anchor. For single anchor. Now this will be NCBG and NCB. NCB for single anchor, concrete breakout strength in tension. N means tension, breakout strength for anchor group. Now we can consider NPN, phi NPN, which is factored concrete pullout strength. Pullout strength for single anchor. Single anchor in what? In tension. In tension. And phi NA is factored bond strength. Without S means bond strength. For single adhesive anchor. For single adhesive anchor in tension. Similarly, if we write here phi NAG, it will be what? Factored bond strength of adhesive anchor group in tension. So we can learn these three. One is the NPN. NPN stands for pull-out strength. N means tension, and for single anchor without any comma, so means single anchor. Phi NA is the bond strength of single adhesive anchor in tension. Phi NAG is the factored bond strength of adhesive anchor group in tension. So in this way we have learned all the N values. Now just replacing N with the V, we can get the shear strength. Now we can just very quickly we can understand this, that VSA, V means shear, S means shear strength, A means for single anchor. So with this we can say it is a shear strength of single anchor. In what? In shear. In shear. Now this will be the concrete breakout strength. Single anchor. And this will be the concrete breakout strength for anchor group. Now these are in the shear because V is written. Now CP, there is no pull out intention, but there is concrete pryout. So we can say it is concrete pryout strength of single anchor in shear. Similarly, this is for the group. And these are for the shear. So we can clearly write down or jot down all this strength. And understanding all this is very major for us because then only we can understand the codal provision very well. Now I can explain you how you will be very well understand all these concepts if we look at the table 17.5.2 of ACI 31825. So let us see what we have accomplished till now. Now this is the table 17.5.2 design strength of anchor, and this is, we can say, the summary which we will design in the anchor bolt series. So these are the failure modes: steel strength, concrete breakout, pull out, concrete side face blowout, bond strength, and tension. These are tension, and now you can clearly understand what does it means. And you can, and these are the shear one. So basically we have to check our anchor bolt stresses in this case. This is basically our design summary. And now you can clearly understand this table because of terminologies. We have understand very well the terminologies, so you can clearly understand the table 17.5.2. So if you like my video, so then please subscribe my channel. This is the end of today's video series. Now we will, in the next video, we will be learning about the code very well. So let us finish this video here only.